Okay, we're going to go into acids and alkalis now. So let's look at, I'll start acid. Okay, what are acids? Acids are actually solutions. Okay, we have pH of less than 7. Okay, this is just a very general introduction of what acids are. Okay, pH less than 7. Note the three names over here. These are the three acids you must remember. Hydrochloric acid, nitric acid, sulfuric acid. These are the three names you will repeat very often in the chapter of acids and alkali. So this is our acid solution. We have pH less than 7. What are alkalis? So alkalis are solution which have pH greater than 7. Okay, so we know acids is less than 7. Alkalis are greater than 7. So some of the alkalis commonly used are sodium hydroxide, potassium hydroxide, and ammonium hydroxide. Take note of these three once again. Okay, so these three are your alkalis that you will commonly use too. So we have acids and alkali, 3 different acids, 3 different alkalis. I've mentioned about pH over here. So what exactly are pH? So pH actually is just a very simple term. It's just a measure of how acidic or alkaline a substance is. Okay, so that's what pH is. Okay, just a measure of how acidic, how alkaline things are. So, how do we tell pH? Actually, what do? We use indicators. So what are indicators? It's actually to tell whether substances are acid or alkali. How does indicator work? They are actually substances that are one color in acids and another in alkali. Okay, so for example, maybe one of the indicator is red in acid. When you put it in alkali, it becomes blue. So you can tell the difference whether something is acidic or alkaline. So some of the common one that you will see is litmus indicator, universal indicator, and the next one is the pH meter and pH sensor. This one is very accurate. Okay, because it is digital. Okay, this too is very general. Okay, very general. You'll understand why later on. So first one we go into is litmus indicator. Litmus is used as a solution or in paper. Normally in the lab we use it as paper. So we have the red litmus paper or the blue litmus paper. Now, to test whether it is acidic, okay, for acidic, what color paper, litmus paper do I use? I use the blue litmus paper. So if I take the blue litmus paper, put it in an acidic solution, what's going to happen? The blue litmus paper will turn red. Okay, it will turn red. So just take note, to test for acidic, which one do you use? You use blue litmus paper. And what will happen to your blue litmus paper? It will turn red. Okay, now, same thing. If I want to test for alkaline, this time I use the opposite. I will use a red litmus paper. So what happened to my red litmus paper? My red litmus paper will turn blue. Okay, so say again. If you want to test whether something is alkaline, I'll use a red litmus paper. What will happen to my red litmus paper? It will turn blue if alkaline is present. Okay, so just take note. This is how your litmus indicator works. It just changes from one color to another, and then you will know whether something is acidic or alkaline. Next one is a universal indicator. It's actually a mixture of many different indicators. So it can be used in a solution form, or it can be used in a paper form. Paper form, it is yellow. Solution form is normally green. So what happens is that at different pH, it changes to different colors. That's why there's a whole range of colors over here that you can see. Okay, from pH 0 all the way to pH 14. Okay, so this range of pH is what we call our pH scale. Okay, it's not only used for universal indicator. Actually, throughout, there's this thing called the pH scale. It ranges from 0 to 14. Okay, different indicators, different substances will have different pH. So the universal indicator can help to indicate whether is it pH 0, 1, 2, 3, or around 10 or 7, based on what color it has become. Okay, Now, in addition, remember we're saying pH greater than 7 is alkali, greater than 7 equals alkali. Okay, less than 7 we consider it acid. Then how about equals 7? If the pH is 7, we term that as neutral solutions, so they are neither acidic or alkaline. One classic example is your water. Water is not acidic, water is not alkaline. It has a pH of 7. That's for your pure water. So universal indicator, when you put pure water with the universal indicator, it will actually turn green. And the last one, pH meter and pH sensor. Okay, this is very accurate because if you can see the things here, it's a digital scale. It can measure pH up to maybe 1.24 or something like this to 2 decimal place. So it's very accurate and it's easy to use. You plug it into your data logger. Okay, what must you do is you must use the sensor, plug it into a data logger. Sorry. This one is the attached one. So in this case, it actually is very simple. You can see, sorry, let me choose this object here. You can see all you need is just take this N here, you dip it into the acid or dip it into a substance. Okay, then the values here will change accordingly. Then you know whether something is acidic or alkaline. Okay, it's just that simple. So, once again, let's look at the summary here. pH values range from 0 to 14. Below 7, acidic. Above 7, it is alkaline. And at 7, it is considered neutral. So you can see some of the examples. Hydrochloric acid is 1, lemon juice is 2, cabbage is 5, water is 7, milk of magnesia is about 10.5, and this thing called lye is about 13. So this marks the first part of our acid and alkali. We talked about the general introduction of acid and alkali, and we moved on to pH.